So let's start with question number 20 of H.C. Verma, volume 2, Gauss law. Why is it so blurred? Huh? Wait, still kind of blurred, but it's all right. Okay, so I'll not do the this question number 20. I'll not do the A part. It's very easy. The B part is what I'm interested in. So this is a sheet, non-conducting plate, the silk thread. This is a bob. Now this angle, I'll name it theta. It's 60 given, and the bob is at equilibrium. You pushed it slightly, so d theta is the slight angular displacement. Given some basic values, like the length of the thread is 1 meter. Mass of the bob is 10 power minus 2. And the charge on this bob is with 10 power minus 6. And the density, the charge per area density, as we calculated in question number 19, we can use it. It's already been calculated. 7.5. So 100 power minus 7. Not use the units. Okay. These are some values that you're given. Slightly displaced rate or find the time period. Now in these kind of questions, you basically know you have a horizontal force, and to this horizontal force, there is no change in the time period of this pendulum for small oscillations. So if you are in some kind of a formal coaching, they'll teach you the formula 2 pi root L by G effective, where G effective is the external force other than the tension experienced by this bob divided by the mass. In this case, you can also say it's the basically the tension divided by mass, since all the other force balance them. Sorry, but this isn't fancy, at least for me. I'll rather prefer using the more conventional way, because there is no proof of G effective, or if there was a proof, I haven't found it. Like, so I do not intend to use made up like formulas that I do not know the derivation of. I do not use such formulas, except of course the fundamental formulas. So okay, so of course I'll derive it from the starting. Let me write the forces. Yeah, this is the force by the non-conducting plate. It's sigma by 2 epsilon naught. Yeah, assuming it's in vacuum. We shouldn't, but we have. This is mg, and this is tension. Now, since it's getting displaced a bit in this kind of an arc, you cannot have vertical equilibrium, nor you can have horizontal equilibrium. You can have equilibrium in this direction, you know, along the string. You can have equilibrium. So I'm going to resolve all these vectors. I think I should resolve them in some. Yeah, I'm going to resolve them in green. So I'm resolving them along the string and tangential to the string. So it's t already. If it's theta, then it's mg cos theta plus d theta. Do not forget this. And, and this is sigma by 2 epsilon naught because this makes 90. It's 90 minus theta, so it will be opposite. Sine theta plus d theta. Hmm. But you do not need the this kind of an equilibrium. Just resolving. It's not needed. You know, just for context sake. Now this is where you actually need to resolve the vectors. I'll better resolve it in blue. So it's mg sine theta plus d theta. And on the other side, that becomes sigma by 2 epsilon naught. Oh, sorry, I forgot the q. Otherwise, it's just the electric field. It's q epsilon naught to epsilon naught upon 2 epsilon naught cos theta plus d theta. We have equilibrium. Except when we have slightly displaced a bit. We have displaced it by d theta, so we do not have equilibrium for the moment. So let's write the formula. We know it's going to be SHM, though I haven't made it clear till now. But we know, of course, it's SHM by the feel of it. Well, I'll prove it anyways. So I think we'll prefer black Mg. You can like have it anyways. You can have this more than this or this more than this. Doesn't matter. Okay. I'll do this. Mg sine theta plus d theta. So yes, theta is increasing the sine theta value. Originally it was sine theta and originally it was cos theta. Sine theta value is increasing and this cos theta value is decreasing. So a fair guess is that this value would be greater than this value, but until the end it'll be no get to know that it doesn't matter. Minus q sigma by 2 epsilon naught cos theta plus d theta is equal to okay I could have written it as omega square x, or x can be written as, since it's a small displacement, d theta l, where l is the length of the string. How did I know this? I did not. I just had a fair guess. Of course, it's going to be SHM. I can prove it later on just using this LHS, but I'm not that lazy, or like no, not that. Okay, I do not have that much time. So mg becomes mg inside its sine theta cos d theta plus cos theta over cos theta and it's sine d theta. It becomes cos theta cos d theta minus sine theta sine d theta. I'm going to ignore the RHS for a moment. Now this cos d theta for small values, of course, it's 1. And this sine d theta for small values, it's d theta. This cos d theta is 1. And the sine d theta, it's just theta, d theta. Now, I said we wouldn't use this. I said we wouldn't, but in fact we are now. How? I'll tell you. I said we wouldn't, but we are. No, we are not. We are not. I'm sorry. I'm sorry. Not. So it becomes in the end mg sine theta plus mg cos theta d theta minus q sigma by 2 epsilon naught cos theta plus q sigma by 2 epsilon naught sine theta d theta. Now just look at this. When the bob was in equilibrium, when this d theta displacement wasn't there, then this mg sine theta must have balanced this q epsilon naught q sigma by 2 epsilon naught cos theta. Must have balanced it, right? So the sum must have been zero. Or the sum of this and the uh, inverse of this, additive inverse of this must have been zero. But it was in equilibrium when the d theta displacement wasn't there. So it's zero. So the thing is zero. It becomes mg cos d theta plus q sigma sine d theta 2 epsilon naught m omega square d theta. Yeah, we are using d theta since it's like we are having small oscillations around this equilibrium with the amplitudes being very small. D theta. This d theta gets cut, of course, L. Now, I have to put the value, right? See, mg is 10 to the power minus 2 and 10 to the power minus 1. And cos of, it's given 60. This theta is given 60. And cos of 60 is 1 by 2 plus this q is given 4, 10 to the power minus 6. Sigma, we calculated in the previous question, is 7.5 and 10 to the power minus 7. What was it? Sine theta d theta, right? Sine theta d theta. Sine theta is root 3 by 2. Saying it's 1.7. It's the half of 1.73 on 4 epsilon. It's halved it into 8.8, 10 power minus 12. This 4 and this 4 gets cut. I think 7.5 into 1.73. How much is it? 75 into 17. How much is it? 750 and 90, 35, 525, 525, and that's 6, 750, 750, 1250, 1250, and I think it's 1275. Let's check. 75 into 17. 75, 5, 7, 1275, yeah. So just kind of approximating it as 12. Why not? It's 12, and this thing is 9. Yeah. And this is 4 by 3. No, I think I'm getting the wrong answer. Wait a sec. I think I've approximated too much. 4 into 10 power minus 6 is 7 into 3 by 2. It's 12.75. It should come out here near to 1.7. It's not. Mistake have I done? That is like let's use the calculator. 7.5 times 1.732 by pi. Now we are getting 1.47. I think we're right then. I think I did not do any mistake. We were getting 1.4, right? This is approximately 1.4. I got 1.3. approximation, but it's 1.4. So, you know, so 8.8 is 1.4. 1.4. And this comes out to be 12 minus 13, which is minus 1, is equal to m is given 10 power minus 2 omega square. I'll write later. L is 10 power minus 1. This gets cut. 1.4 and half is 1.9. I'll approximate as 2. And 2 into 10 power minus 2 omega square is 4 pi square by t square. My god. And so t is equal to 2 pi. Root of 10 power minus 2 is 10 power minus 1. 1 by root 2, that is root 2 by 2. That's 1.41 by 2. Now pi is 3. For engineers, it's 3. Just kidding, it's 3.1. So 2 and 2 cut. 3.1 into 1.4. Let's do it already. 14 threes are is 42. And 42 and 14. That's 434. That's, I think, that's 4.34 by 10, or like 0.43 seconds. It's I'm getting after approximation. Not know the, please check it. It's root 2 pi, basically. Pi root 2. Uh, Pi root 2 is 4.44. The answer is going 0.45, and that much approximation is all right. Actually, approximately that value to be 2, it should be 1.9. No, 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 not 1.9. Was it 2 pi by, yeah, 2 pi by 10 root 1 by 1.9. It's 0.45. That's the answer. 0.43, 0.45. Okay, so we're done. Congrats.